let's explore the distance formula. In a minute, we'll give an algebraic definition of the distance between 2 points. Let's start by exploring what we would think of as the geometric distance between 2 points. Let's illustrate this with the example using the following 2 points. 4, 9 and negative 1, 2. Let's draw a picture. X-axis, the y-axis. Let's plot these 2 points. 4, 9 up here. And over here, negative 1, 2. There's exactly one line segment that connects these 2 points. Let's draw it in red. This line segment right here. And what we think of as the geometric distance between these 2 points is the length of this red line segment. We'll label the length as d. Let's see if we can come up with an algebraic expression for d. Let's draw a triangle. We can form a right triangle. There's this vertex down here, which has coordinates 4, 2. So what is d, the length of this hypotenuse? Well, we can use the Pythagorean theorem. Let's figure out the length of the 2 legs. For the horizontal leg down here, it's the distance between, you can think of its length as the distance between x equals -1 and x equals 4, which is represented using absolute value. The absolute value of -1 minus 4. And for the vertical leg, its distance will be equal to the absolute value of 2 minus 9. The distance, you can think of it as the distance between y equals 2 and y equals 9. So the Pythagorean theorem says that d is the square root of the length of the horizontal leg squared plus the length of the vertical leg squared. Let's evaluate this. This is the absolute value of -5 squared. This is the absolute value of -7 squared. So we get 25 plus 49 as the radicand. This is the square root of 74. And of course, we would want to simplify our radical as much as possible in the end. 74 has no perfect square factors. So this is the distance. The square root of 74 units. And we will use this to give the definition, the algebraic definition. If we have 2 points, so these will have unknown x and y coordinates. We'll label them like this. The distance between the 2 points is the absolute value of we'll just do exactly what we did in the example. The difference in the x coordinates, take the absolute value of that and then square that plus take the difference in the y coordinates, the absolute value of that, and then we square that. And it turns out that if we can drop the absolute value, because for any real number, t, we have that t squared is the same as the absolute value of t, then squared. So this turns out to equal this formula, which is what we use for the distance formula between between P1 and P2. Right here. So the definition we give is exactly what we geometrically think of as the distance between 2 points.